Hi guys, welcome to example one. This is now my third attempt at making this video. The first time I recognized I had a typo on problem B, so my apologies for those of you who did the problem as it was written. And then the second time, my headphones died. So here we go. Let's try for number three. When we look at these problems, we're going to see if they're geometric. And I can plainly see that if I multiply by -5, I get -15. So if it's geometric, the same would have to be true here. And if I multiply -15 by -5, I do in fact get 75. So that tells me that it does appear to be geometric. And the common ratio would be -5. Part B, if you went ahead and did it as I had shown it at the end of example number one, or the warm-up, you would see that it was not geometric. I had a typo there. But now, as written, as it was intended, if we were to multiply the top by 2, 1 times 2 is 2. So if it's geometric on top, we'd have to keep that pattern going. And 2 and 2 does make 4. On the bottom, we can see that 5 times 3 is 15. So if it is geometric, this would also have to be a 3. And 15 times 3 does equal 45. So that, once again, makes it geometric. And the common ratio would be 2/3. Multiplying the top by 2 and the bottom by 3, that's the ratio of 2/3. And the last one, if this is a geometric, then that means to get from a 1 to a 2, I'd have to be multiplying by 2. But if I multiply 2 times 2, I do not get 3. Furthermore, the denominator is not being multiplied every time it's being added, so this one is not geometric. And that wasn't a typo, that was actually intended. All right, so we have our 3 answers to those. All right, example number 2, we're just going to keep on rolling, and hopefully my headphones don't die again. This time, we are going to be taking the same examples from above, and we're going to be writing the nth terms. So if we do this, so one way of looking at this to be very organized is we could just make ourselves like a little chart. What term are we on, and then what's the value? Or what's the pattern that we're going to see? So term 1, we just have a 3. Term 2, we have a 3 times a -5. Term 3, we have a 3 times a -5 to get the -15. Right, that's just the answer from before, but then we're multiplying that by another -5. So if we look at this pattern, we can see that we are just taking a 3 and we're multiplying it by a -5, and we're doing so, this is term 3, we did 2 5s, term 2, we did 1 -5, and term 1, we did no -5s. And so I think it's very clear to see that in fact our pattern should be 3 times -5 to the n-1 power. So that would be my nth term. On this one, if we do the same thing, we can see that term 1 is simply 1/5. Term 2 is a 1/5 multiplied by 2/3. Term 3 is 1/5 multiplied by 2/3 and then another 2/3. 2 times 2 is 4. 5 times 3 is 15 times 3 is 45. So once again, we're multiplying by 2/3 that common ratio each time. And as before, we have 1 less than the term that we're on. So this is going to become 1/5 times our common ratio, which is 2/3 to the n-1 power. And if you can figure these out, and I'm sure that you can without making this pattern or drawing it out like this, then please go ahead and do so. As I look at this one, this is the first term, this is the second term, this is the third term. And you'll notice the numerator just corresponds to what term we're in. So if I'm going to write this, I think we just have an n on top. That would cover that. And on the bottom, we have an arithmetic sequence because we're just adding 2 each time. So we can go ahead and use the formula for the arithmetic sequence, or we can just sort of recognize that if we basically find the 0th term, we'll have the statement. So if I were to back up one more to find what happens at term 0, then this would be just focusing on the bottom, not the numerator. We've already had that figured out. Then we would have 3. 3 plus 2 is 5, plus 2 is 7. And so simply here, what is the slope? 2n, and where did we start? We started at 3. So 2n plus 3. And we can check it. First term, 1 times 2 is 2, plus 3 is 5. Second term, 4 plus 3 is 7. So there is your nth term. Alternatively, we could have just done the arithmetic formula. The numerator, our first term is a 1, and then we're adding a common ratio of 1 each time, and we're doing that n minus 1 times. The denominator, we're starting with a 5, and then we're adding 2 each time, and we're doing that n minus 1 times. So those are the formulas for arithmetic, both of which will simplify into what we have right here. And then finally, we have part D, which is simply us really kind of trying to figure out what is the nth term. And so when we look at this, of course, it should be of no surprise. As we've noticed, all we're doing is we're taking the first term. So the nth term is going to simply be the first term, the a. Notice the a is present in every one of these. And then we're multiplying it by r. And this is r to the 0 power, r to the first power. This is term 1, this is term 2, term 3. So we're always going to be 1 less than the term. And so we get a sub n equals a times r to the n minus 1. And this is our formula for finding the nth term of a geometric sequence. So if you were a formula person and you want to memorize something, this is what you would memorize. But honestly, it's easy enough just to figure out by looking at the pattern. All right, hope this helps. We'll see you on the next video.